Michael Lemming, and today we are doing the Physics Bucket Challenge. Today I'll be swinging this bucket first, and then Preston will go second, and then we're going to talk about why it happens and what happens. I'll give it a start. Oh! Alright, as you can see, the water did in fact stay in the bucket. Give it Preston's turn. There we go. As you can see, water stays in the bucket. This is because of centripetal force. All right, the reason that the water stays in the bucket is because of the equation Fc equals mv squared over r. This means that the faster me and Preston swing this bucket, the more the centrifugal force increases. And that's why the water is able to stay in the bucket. If I were to go ahead and swing this really slow, the water would fall out because there isn't enough velocity to make the centrifugal force strong enough to keep the water in the bucket. Top of the swing, the gravity is pulling the water downward, which means that the water already has enough speed to continue moving, and the bucket provides inward force so that when you swing the bucket with water filled inside, the water will not travel out of the bucket, and this is because of the inward force the bucket has when swinging it. All right, finally, Newton's first law says that objects will stay in motion until acted upon. Therefore, when me and Preston were to swing this water, like so, the water is already moving with the bucket, and there's nothing that's stopping the bucket from keeping moving in that circular motion. Therefore, the water has no reason to get stopped or to get disrupted, which would cause the water to come out and splash all over one of us.
Here we go. Michael is going to be showing you guys what happens when centripetal force is not being used, and he's going to slow the bucket down, meaning that the inwards force of the bucket on the water will stop and the water at the top of the swing will come out. Here we go.
Here we go.
Nice.